Hi class, in this video we're going to be talking about multiplying polynomials. So to start us off for our first example, we have n times n. Now to solve this one, we have to use our exponent laws. So recall when I had, let's say, 2 to the power of 2 times 2 to the power of 4. When I have the same numbers with the same base, which is 2 and 2, what I can do is just add the exponents together when I multiply them. So this would just be 2 to the power of, or 2 to the exponent of 2 plus 4, which is 2 plus 4 is 6, so I get 2 to the power of 6 here. I can do the same for n. So there's an invisible 1 as an exponent for my n's, and that just tells me how many times I times n by itself. In this case, it's just n. So for this one, when I solve it, it's just going to be n to the exponent of 1 plus 1. So when I multiply the n's together, I just add the exponents. So n to the power of, or n to the exponent of 1 plus 1 would just be n to the exponent of 2. So that's my answer here. Now for question 2 over here, I have r times r squared. So this dot just means multiply. So the reason I use the dot is because this multiplication symbol here looks very similar to the variable x. So to avoid confusion, what I'm going to do is either I write this as just r and r squared in brackets, or I just write it like this with the dot to show that it's multiplying to each other. In this case, I chose to write it like this. Now, to solve for this question, there is an invisible 1 once again for every variable that doesn't have any exponent. So to solve for this one, it's just going to be r to the exponent of 1 plus 2. So when I multiply it together, I just add the exponents. And I'm able to do that because I have the same base. Both of the bases are r. So in this case, I have r to the power, or r to the exponent of 1 plus 2, which is r to the exponent of 3. So that's my answer there. Now, let's move on to our next question. We're going to solve for question 3. X to the power of 3, or the exponent of 3, times x to the exponent of 0. So in this case, because my base are the same, I can just add my exponents. So this would be x to the exponent of 3 plus 0. But 3 plus 0 is still 3. So my answer here would be x to the exponent of 3. Now, another way to think about this, any number to the exponent of 0 is 1, except when x is equal to 0. So in that case, you could also write this as, or you can also write this as x to the exponent of 3 times 1. And that still just gets you x to the exponent of 3. So either way works, but if you use this method, you would have to recognize that in order to get 1, you got it because a number to the power of 0 would equal to 1. Except that number cannot equal to 0 because 0 to the power of 0 is actually 0. But any other number to the power of 0 would be 1. So that's just a review of exponent laws that you can watch in one of my previous videos. So now moving on to our next question. Y squared times y cubed. Because y are the same bases, what I can do is I can just add the exponents. So this would be y to the exponent of 2 plus 3, and 2 plus 3 is 5, so my answer is just going to be y to the exponent of 5. Okay, now moving on to another example here, I have 9 times p to the power of 4, or to the exponent of 4, times 12 times p to the exponent of 6. So what I can do here is I can rearrange this. So this just is written as 9 times p to the exponent of 4 times 12 times p to the exponent of 6. So why don't I rearrange this? So notice that my numbers are the same and my base for p is the same. So let's just rearrange it right now. If I choose to rearrange it, let's move the 9 closer to the 12, and then we'll move the p next to the p. So in this case, now let's solve these. So once again, my numbers are still the same as my numbers, so I can most likely multiply them together. And my p's have the same base, so I can also multiply them together. So in this case, what is 9 times 12? Well, 12 times 10 is 120, so 9 times 12 must be 108. So I'm going to have 108 now. So I just simplified this question that I have, and now I have p to the exponent of 4 left and p to the exponent of 6 left. Now I can simplify my same base exponents here, or same base powers, which are my p's. So for this one, I still have my 108, and I'm going to multiply it to p to the exponent of 4 times p to the exponent of 6. Now, because they have the same base, I can just add my exponents together. So this would be p to the exponent of 4 plus 6. So this would be 108 times p to the exponent of 10. And because this is multiplying and these are algebraic expressions, I don't need to write this dot anymore. So I can just simplify my final answer as 108 p to the exponent of 10. And that's how I would leave my final answer. Now, looking at question 6, same idea. My numbers are the same as my numbers. We want to underline our numbers with a different color. I'm going to underline the ones that I have the same base for. So A, and then B, I don't have anything the same for B. I only have one B here. So I'm going to have 11 times 6, which is 66. A to the power, or A to the exponent of 4 times A to the exponent of 6 would be A to the exponent of 10. And then there's no other b here, so I just leave it as b to the exponent of 3. So my final answer is 66, a to the exponent of 10, and b to the exponent of 3. Now moving on to question 7, I have u to the exponent of 3 times v to the exponent of 3. Now notice I don't have anything that is the same base here. So what I'm going to do is I can just write this as u to the exponent of 3, write a 3 here, and then write v to the exponent of 3. But however, we're also taught in expressions, we want to let the number be the first thing we put on the left side, and then we want to order the variables alphabetically. So a better way to write this would be to put the 3 first, then order alphabetically. So u comes before v in the alphabet, so then we put u to the exponent of 3 and v to the exponent of 3. So notice all I did was rearranged. I couldn't simplify this anymore except for rearranging because I only have one u, one v, and one number. So I leave this as 3 u to the power of 3 and v to the power of 3. Okay, now let's move on to number 8. So for this one, it's the distributive property that we talked about before, except now I have a variable on the outside. So it's going to be 3r multiplied to 7r and multiplied to the negative 8. So I multiply the polynomial I have on the outside to the different terms that I have inside the bracket. So this is going to be 3r multiplied by 7r, and then I'm going to have 3r again multiplied by negative 8. So in this case, 3r times 7r, first let's multiply the numbers. 3 times 7 is 21. Now r times r, remember there's an invisible 1 as the exponent for my variable. So this would be r to the exponent of 1 times r to the exponent of 1. Because I have the same base, I can add the exponents together. So this would be r to the exponent of 1 plus 1. And 1 plus 1 is 2, so this should be r to the power to the exponent of 2. So r squared. So I have 21r squared. Now I'm going to add 3r times negative 8. Well, in this case, I don't have another r here, so I just multiply the numbers. 3 times negative 8 is negative 24. So I have negative 24r. And now to simplify this more, I can just write this as 21r squared minus 24r. So I just changed this plus sign to a minus, and this is still the same answer, but it's more simple this way, rather than just leaving the negative in the bracket. So that's my final answer there. Now moving on to question number 9, same idea, the distributive property. So I multiply 10a into a and into 10b. Okay, so I have 10a times a plus 10a multiplied by 10b. In this case, 10a times a is going to be 10 a squared, and 10a times 10b, well, 10 times 10 is 100. Now a times b is just going to be ab. Okay, and I can't simplify anymore, so that's my final answer here. Okay, here for question 10, I have 2 times k to the exponent of 3. I'm going to multiply that into my 3 terms here. Okay, so I'm going to have 2k to the exponent of 3 times 2k to the exponent of 2 plus 2k to the exponent of 3 times 5k plus 2k to the exponent of 3 times negative 4. Okay, so for this one, 2 times 2 is 4. Great. K to the exponent of 3 times k to the exponent of 2 is k to the exponent of 5, because I just add the exponents together when I multiply up the same base. Now, 2 times 5 here is 10. K to the exponent of 3 times k to the exponent of 1 is k to the exponent of 4. And now I have 2 times negative 4 is negative 8. And there's no other k, so I leave it as k to the exponent of 3. Now, to simplify my answer, I'm going to have 4k to the exponent of 5 plus 10k to the exponent of 4. Now, instead of adding negative 8, I'm just going to write minus 8k to the exponent of 3. And that's my final answer there. And hopefully that gives you a good idea of how to multiply all these different forms of polynomials.